Hello everyone and welcome to our webinar for today, the voice lift system design. We are going to be talking about voice lift systems for meetings and conference rooms today. We'll also be taking a look at some of the features, benefits, and technical issues that you might need to keep in mind when you're designing or implementing such a system. So firstly, let me introduce the team. Today's presenters are Anish Samuel. I'm from the System Applications team at Shure Middle East and Africa. Joining me is Ritendra Podar from the System Applications team, Shure Middle East and Africa. We are the point of contact if you have any technical or design related queries related to Shure system products. Before we get into the main presentation, here are just a few points to keep in mind. This webinar is on BlueJeans platform. We would request you to please select the low bandwidth option to avoid any interruptions. Please wear headphones or earphones for a better quality audio experience. If you are experiencing any issue with audio, not to worry, as the webinar will be shared soon. Participants' video and microphones are muted, so it is a one-way communication. And participants are requested to answer polls that are active during the webinar. Please type your questions in the chat or the Q&A box, and we will answer them at the end of the session. So thank you in advance. A few words on the webinar setup. As you are already aware that the current situation has forced us to rethink the way we operate our businesses, there is a need for social distancing and remote working strategies to be in place. So as a result, professionals have now turned on to AV conferencing to stay connected with colleagues and customers and to operate business without disruption. So AV conferencing seems to be actually providing a more personalized experience. And it also serves as the closest alternate to a face-to-face meeting. So meetings are conveyed or messages are conveyed more quicker and the concerns are addressed more effectively. So effective communication is therefore very critical during this trying time. And to keep businesses running very smoothly, it has to be ensured. So as Shure has more than 90 plus years of experience in delivering quality audio products, we would like to support you with technologies that are effective for communication. So keeping this in mind for this webinar, we have done our home office setup with actually a Shure Motive line of products. So right now, I'm having a Shure MV51 microphone connected via USB with my laptop, and I have a headphone and a USB camera connected as well. My colleague Ritendra has a Shure MV5 digital condenser microphone connected via USB with a Shure SRH145 headphone connected and a USB webcam for video. So some key features of the Motive is being discussed here. The setup is very quick. It supports plug and play. So no drivers are required. It is built in with a 3.5 mm headphone output for expansion. It is compatible with smartphones, PC, and Mac. It has a built-in DSP with functions like limiter, compressor, and equalizer all built in. So MV5 has 3 DSP preset modes, which is like vocals, flat, and instrument modes, while MV51 has 5 DSP preset modes like speech, singing, flat, acoustic instruments, and loud mode. So it also offers seamless integration with AV applications and soft codecs like Skype, BlueJeans, and Teams, etc. The Shure MV5 also offers flexible mounting options with its microphone's standard threading. And the Shure MV51 is the same. It also offers flexible mounting options with its microphone standard threading. And it also has a durable touchscreen front panel to ensure longevity of the product. So it's actually worth noting that we are not going to be able to teach you everything, every single thing that you would need to know to successfully design a voice lift system. But our intention is actually to set you on the right track. We'll be having the following course objectives as of now. Number one, we'll be determining if your facility is a reasonable candidate for a voice lift system. So the important point here is that not all rooms allow for a voice lift system to actually function in the way that you might expect. Second is to learn about the selecting of the right microphone system, that will allow you to obtain your desired results. Because not all microphones are created equal. Like some of them are better suited for some applications while others are not. And we'll be discussing some of the ins and outs of choosing a microphone for a voice lift system. So the third is to calculate the amount of gain you can expect to achieve as part of your system design. So believe it or not, you can actually use mathematical formulae to come up with a pretty good prediction of the voice lift as to whether your voice lift will work or give you the benefit that you're looking for. And finally, we can determine the benefit. Will the benefit justify the cost of implementation? So, as a voice lift system can be quite expensive, especially when you compare it with a traditional sound system or a sound reinforcement system. So it's worth having discussions with the client in advance to set the expectations and the cost, and it will ultimately help you and them to make an educated decision. So a lot of what we are going to talk today is like how to make an educated decision about voice lift in general. So the course structure is as followed. What is voice lift? Doing the math. We'll be touching inverse square law and PAGNAG, loudspeaker considerations, microphone considerations, and any other considerations. What is voice lift? To start off with, I think we should define what is voice lift and what do we mean by that. So in the simplest way we could possibly explain voice lift, that it is an attempt to provide just enough sound reinforcement within the room so that the farthest listener from the sound source can hear just as well as the closest listener. So you can actually see that in the pictorial. So as you see in the picture, the person standing closer to the source is also called as the unaided listener. He's hearing the sound at a certain level. And the goal from a voice lift system is to achieve the same level of audio as the unaided listener at the farther level position. So this is worth pointing out that because it is a different technology than that of a traditional sound reinforcement system, or what people sometimes call as a PA system. So for a PA system, often you're trying to amplify a voice to make it more louder to a point where it sounds quite unnatural. So it is louder than what we would you would expect from a normal conversational speech level. So actually by reinforcing, you are actually exceeding the natural level of sound. So in a voice lift system, or in a particularly well-defined or a designed voice lift system, the farthest listener may not even realize that there is actually a sound system at work or in play. So until you turn the system off, they'll start realize that they can't hear the main talker or the main sound source any well. So it's a much more type of a subtle kind of reinforcement that can typically, you can have it with a system, and sometimes, it won't help you justify the cost benefit analysis because, people may not feel like, or they might not understand what they just paid for, or they might not notice anything until you turn it off. And then they would realize that what is the benefit of the sound system implemented. So to reiterate, for any of the unaided listener who can hear the talker just fine in an unamplified scenario, you want the person at the far end of the room to be able to hear just as well. So that's your goal with a voice lift system. So oftentimes the voice lift system is also deployed in conjunction with a AV conferencing system. So you might have a room where you already have set up to conference with other locations, and the microphones might have been used to bring your voice to another location. But if it is a large enough room, there might also be a requirement for a voice lift so that, other participants in the same room can hear just as well as the closest listeners are. A digital signal processor of some sort is actually required for the complex signal routing and the system adjustments that are needed for a successful voice lift system. The voice lift is more complex than a traditional, speech reinforcement system, where you might already know where the talker or the presenter is presenting from. It can be typically from the front of the room. So a traditional system can be like a couple of speakers, installed on stands, or with a handheld mic, and you are probably in a good shape to present. But to make the voice lift system work in a desired way, we have to factor in considerations like, there are multiple participants within the room, large room size, and challenging acoustics of the room, etc. And it is going to be a much more complicated system than your traditional, sound speech reinforcement systems. So, hence I would like to re-emphasize on my earlier point that we might not be able to teach you everything that you need to know today, but hopefully we can set you down on the right path. So one of the few things that you really need to think about is determining if your facility can benefit from a voice lift. So there are some questions that you need to ask before heading down this path. One of which might be like, is there an existing facility with an installed sound system? So you're going to learn a little bit about the microphone signals getting routed between the room speakers and which loudspeakers they're getting routed to, or their relative position between these devices. It all determines whether or not a voice lift system is going to be successful. And if you're already kind of logged in with certain elements because the system is already installed, this could further affect the overall results or the success of the system. So another really important question is, does the room even need a reinforcement? Because sometimes, voice lift is thought of something like it should be added just because you want everybody within the room to be louder. But you need to really sit and analyze the room and have a meeting or a conversation in there and really determine if the voice lift system is actually required. Because chances are that if it is not actually needed in the room, trying to make it work within the room is going to be even more challenging. So it is a very important question to ask whether it is really required or not. Of course, the type of microphone that you're using will also play into this. And when we start talking about the mathematical formulae and how these relationships matter here, like the mic type, its placement within the room. Sometimes architects specifying where to place in some cases, and impact on whether or not you can actually even have a microphone on the table, or you may have to find an alternate solution to the mics on the table, which means that the microphone must be far away from the talker. So it can further complicate things, and all of these needs to be considered when we are factoring in for a voice lift solution. And finally, the environmental conditions or the acoustics within the room is also important. Like, is there any background noise present in the room when we talk? We'll be discussing that in detail as we go further into the slides. And also the details on the physical room itself. It is actually a deciding factor for the success or failure of a voice lift system. The final point here, which has been italicized, is that the introduction of voice lifts into an existing conferencing system will affect the performance of the acoustic echo canceller. So if this is actually being implemented in a room where you're already doing like AV conferencing of some sort, the presence of a voiceless system will impact how the acoustic echo cancellation or the echo canceller works. So we might have to revisit the system and make further adjustments to compensate for the fact that we are now adding voice lift as well. So we are going to discuss how a mathematical formula can be used to aid in voice lift calculations. The first thing that we are going to be looking at is the inverse square law. So the rule of thumb for this is that you will be having a 6 dB drop for every time you double the distance from the source. So this is what you see here. So for the laws and equations we are going to discuss, the assumption is that both loudspeakers and microphones are omnidirectional in nature. So actually we are well aware that there are no pure omnidirectional components, and the systems that we are installed will affect somewhat what the results are, or what the final results or overall results would be. But for the purpose of calculating things, we are assuming that a fully omnidirectional source and a fully omnidirectional receiver is being used. Okay, now with respect to the inverse square law, there is an equation for that, which is particularly judged with distance. And the equation is like 20 log R1 divided by R2, where R1 is your first distance and R2 would be your second distance. Now, if we look at the rules of the thumb for the inverse square law, if we have calculated or measured a value at a known distance and we cut that distance in half, we are going to get a 6 dB increase. And if we increase that distance by half, we are going to lose 6 dB. So consider a situation where you don't double it or you don't cut it in half. The 20 log R1 and R2 will give you values depending upon where your first distance is, which is typically calculated in SPL, and its relativity with the second distance. So either you will get a positive value or a negative value when you run that equation. So it works actually it works quite well in both directions. The inverse square law for sound energy indicates that we lose 6 dB for every doubling of distance from the source. Conversely, we pick up 6 dB of gain every time we cut the distance to the source in half. That's what is being shown here in this pictorial. The next is PAG-NAG. And the inverse square law is heavily being utilized in the PAG-NAG consideration as well. So PAG stands for potential acoustic gain, and NAG stands for needed acoustic gain. And this is the method that has been available since the late 1960. So it has been under use since the late 60s. And PAG-NAG is a concept that can be used to determine if a sound reinforcement system can produce enough gain to provide an optimal listening experience before causing feedback. The PAG stands for potential acoustic gain, or the maximum amount of gain a system is capable of producing before causing feedback. And NAG stands for needed acoustic gain, or the amount of gain required for the farthest listener from the audio source to hear equally well as the nearest listener can hear. So if PAG is greater than NAG, a system will operate without any feedback. And if PAG is less than NAG, a system will suffer from feedback before providing an optimal listening experience. So you can calculate the gain of a sound reinforcement system under this design, and there is actually a big, long, scary equation that we have that you can see here. And the front part of the equation is actually the needed acoustic gain, and the back half of the potential is that of the potential acoustic gain. And the variables in this equation are the number of open mics or NOM. And if you have like 1, 2, or 3 microphone open as part of the system, you are going to have that value affect the overall math or overall value. So the feedback stability margin is also considered as a factor here, because it essentially is your headroom, and for most of the part in voice lift systems, we are looking for at least a 6 dB feedback stability margin for safety stake. And the equivalent acoustic distance is a distance between the source or the talker and an unaided listener, so that the speech is still heard unamplified. And as a result, or at a reasonable level, you're going to need to know what that distance is at that particular level. So D0, there are different parameters like D0, D1, D2, and DS. So D0 is the distance between the talker and the farthest listener. D1 is the distance between the closest loudspeaker and the microphone. D2 is the distance between the loudspeaker closest to the farthest listener. And then finally, DS is the distance between the sound source to the talker and the microphone. So probably the two most important components here are the DS and the D1 value, because here we are trying to get the microphone as close to the talker as possible and as far away from the active loudspeaker as possible. So if you do that, you can actually receive some additional benefits with respect to the gain before feedback in the system which you're actually designing. Now, here we can see a picture of a more traditional conferencing base. And actually the good news is that there are spreadsheets and websites available that does the calculation for you. So you don't have to worry about the scary calculation that you saw on the previous page. And Shure is amongst one of the people that can give you that calculator, and it is available in our website, and you can use it to your advantage. So my colleague will be taking you through some of the particulars and how to plug values into that calculator later on. So the potential acoustic gain calculator is available on Shure website. Again, there are other calculators as well, but this is the one which Shure can offer. And you can find it by going to shure.com and just typing like PAG in the search bar. So it should be the first thing that comes up when you do that searching, and can utilize that. And you can definitely use the units to your convenience. Like you can put it in feet or meters. So it's all available there. And you can choose your microphone type. You can. There are different microphone types available, like gooseneck, boundary, and hanging. But bear in mind that it is mostly for visualization purpose rather than anything else. And also you can enter values like NOM, DS, D0, D1, D3, etc. So how do different microphones types affect PAG and NAG? So the PAG equation assumes that omnidirectional components are being used. So it is more like a worst case scenario that is being shown here. But if the equation yields positive results under these conditions, you can feel very confident that the system will operate successfully, even when you're using directional microphone. So you can bear in mind that highly directional microphones such as the Shure MXA910 ceiling array will offer you a greater advantage. And it can also often succeed, even when the hanging microphone indicated above will not. So, but you need to carefully, handle the design and, before attempting the voice lift when you're going for an overhead microphone. So let's speak about some loudspeaker considerations here. So it is one of the ways that you can have the ability to increase D1, which is to create more loudspeaker zones, where D1 is the distance between the microphone and the loudspeaker. So I would say that a voice lift system requires a loudspeaker output in a given zone is devoid of a microphone that is active in that particular zone. And this is actually a method by which we can increase the D1 in a voice lift system. So where D1 is the distance between the microphone and the loudspeaker. So this is often referred to as a mix minus methodology in the past. And the voice lift system used to be referred as a mix minus systems in the past. And traditional analog systems would let users play with like the polarity or the phase or the gain, and would let them try and subtract the local microphone out of a particular mix. This is done in order to get a higher level of gain before feedback. So in these days, we are pretty much looking at a DSP product to give us that functionality via matrix mixing or any other examples that we have. And also we are looking at separate outputs for each loudspeaker zones. So as we mentioned, voice lift requires that the sound output in any given zone is devoid of a certain microphone that is active in that particular zone. So here's a picture, showing that we are not routing a particular microphone audio to a person sitting closer. There's a speaker right on top of it, and this particular microphone audio is not being routed here, while it is being routed to the farthest person sitting here via a speaker just above him. So again, this is an attempt to increase the D1 distance, where D1 is the distance between the microphone and the loudspeaker. So this distance is actually very critical for us to achieve some very good, reasonable gain before feedback. And mix minus actually provides us a discrete mix for each loudspeaker zone. which eliminates reinforcement of any microphone in that particular zone. So in order to facilitate voice lift, you have to design loudspeaker zones in the system, which are actually discrete mixes that are coming out from your DSP. So the more the zones you create, the greater the flexibility you have to adjust the system during commissioning and to achieve optimal gain before feedback in all scenarios. So in the simplest of voice lift systems, a minimum of 2 loudspeaker zones are required. So there is no way, with any microphone, you can create a voice lift system with a single zone loudspeaker system, as it is not practical at all. So we have had people try with single zone systems, but it is not going to work at all. So in its most simplest form, you're looking at a 2-zone system, and when you're aiming for a voice lift application. So each zone will require a separate amplifier channel, and sometimes the use of Dante PoE based speakers will allow you for a much more flexibility in establishing zones. So when we talk about loudspeaker zoning, ideally you would increase the number of zones, which gives you more flexibility and which will let you achieve maximum gain before feedback from the system. And also you can apply something called as gain shading. Gain shading is when adjacent zones may be able to route a little bit of an active mic. Say, for example, you have a mic in zone 1. You can route the audio of the microphone in zone 1 to zone 2 and zone 4 at a reduced level, because it is still more closer to zone 1. But you can definitely ramp up the gain of the microphone audio that is going to, from zone 1 to zone 3, because it is relatively far, while zone 1 will not have a copy of its own audio playing through these speakers. So again, it is actually increasing the D1 distance that we are looking at increasing for optimal voice lift. And the other thing that you can do is you can also employ newer Dante-based PoE speakers that gives you the ability of increasing your zones quite easily, because each loudspeaker that it has a direct home run back to the switch, and it can be essentially you can make it as its own zone, and you will also have the ability to change that on the field in case for whatever reason you want to change it, and it is very easy to configure also. So each zone will be having like a separate amplifier channel, and the use of Dante-based PoE speakers will give you more flexibility in establishing zones. So moving on to loudspeaker types and locations, typically we are looking at ceiling loudspeakers for voice lift based application. You could also do this with a wall mounted speaker if you wanted to do it, but it might add some more complication, but distances will still be an issue, and you need to look at it early on, right from the design stage itself. So if you're looking like a traditional 100 volt or 70 volt system, you need to have a separate amplification channel for every run of loudspeakers. And each zone will need to have an amplification channel separate from the others. And again, as I mentioned before, Dante-based PoE speakers makes the creation of zones a much more easier process than the traditional 70 volt system, and also gives you the ability to reconfigure it at the field. So I am going to hand over the floor to Ritin for the rest of the session. So please feel free to raise any questions, and we'll be answering them shortly. Thank you for your patience.
Thanks, Anish. Thanks for defining the voice lift and sharing the key consideration to achieve that. Hello, everyone. I'm Ritain, and thanks for joining us here today. As we were not having any webinar last week, so hope you guys didn't miss us last week. and had a lovely Eid holiday. We are back with our weekly webinar now. So our next topic for today's webinar is microphone consideration. So okay, so when you think about achieving voice left microphone consideration, plays a very important role, and it needs some mathematical calculation. So as mentioned in previous slide by Anish, based on the talker and listener position and microphone speakers placement, the calculation of PAC value explains how much gain the room can offer for voice lift. It justifies the potential of the room, and NAG helps you to know how much gain the room needs at least to have the effective voice lift. Greater the PAC value helps to understand how much exactly the room can accommodate, and the needed acoustic gain is basically going to tell you what is required for the room. So if you see in this slide right now, the room is having a kind of seating arrangement. The talker is sitting here with the boundary or gooseneck microphone, and there are listeners at the other side. So the distance from the microphone for the talker is around 2 feet, and the nearest listener is 6 feet, and the farthest listener is somewhere around 18 feet. And the height of the speaker from the farthest listener is somewhere around 5 feet. So this consider a scenario like this. So for such room, you may, as per the calculation, what you see, the needed acoustic gain is 10.8 dB. So with the help of this tool, what we offer on our website, you can enter the values to calculate based on your scenario or your equipment placement and seating arrangement. So to justify here, have a look. The distance from the microphone is around 2 feet, and it gives you somewhere around 19.4 dB of potential acoustic gain. But the room requires only 10.8 dB to have effective voice lift, right? So this calculation will tell you what exactly you need to do. Now, if you see, this microphone, which is at 2 feet, can also be routed on the nearest speaker somewhere here on zone 2. It is not routed in zone 1 because technically you do need the reinforcement or voice lift in this area, because the listener who is sitting next to the talker can easily hear to the talker without having any kind of system to be placed there, right? Now let's move to the next scenario. Over here, the scenario is with ceiling microphone flushed over there, and the microphone distance increased to 6 feet over here. And in that case, you will see the same room, which was require a needed acoustic gain of 10.8 dB. The room can only offer you the PAG of 7.7 dB, which is lower. So the system will suffer from feedback immediately after you implement the system. So if you see here, zone 2, which is somewhere around 7 feet of the distance. So Z2 is basically talker to the nearest listener, which is 6 feet. So if you route the microphone to the nearest speaker, which is on zone 2, it will go for the feedback. But the system is not gonna work. So what you can do, you can look on this scenario where you're not gonna route the audio of the microphone to the zone 2 speaker. You can only route the audio to the zone 3, which is here at 11 feet. And you can see that the potential acoustic gain increased to 11.6 dB, and the needed acoustic gain is 10.8 dB, which means that the room can offer you the voice lift, but as the value is very close to PAG value, so the system may suffer from feedback. So you need to look on the calculation and keep at least 2 to 3 dB of buffer to have the system like that. Now, so I guess you understood that when you are routing the audio to zone 2 speaker, it was not capable to do the voice lift, but when you routed the audio to zone 3 and not routing on zone 2, it can offer you some kind of voice lift for few dB. Yeah. So by putting the microphone toggle to microphone value, it gives you the value of PAG and NAG. Okay. One more thing I would like to emphasize here is the number of open microphone. To be very accurate, we say let's keep 2. For example, you kept 2 number of open microphone, and then you get the value of PAG and NAG, and you can see what is coming out from the system, what is the value of PAG, what's the value of NAG, and then you can think about implementing the system. When you use the auto mixer, you can enable. If you see here, are you using an auto mixer? When you click on yes, by clicking on this, it automatically takes the number of open microphone to 1. So depending on the way you want to be very accurate and be sure if the system will work, it's always better to keep the number of open microphone manually and see what exactly it can offer. And when you have the auto mixer, of course, the technology will help you to compromise the number of open channels, and that can give you better result. Talking about this slide where we have the ceiling pendant microphone, which is at 4 feet of distance from the talker, it will give you more potential acoustic gain because you are coming closer to the microphone. So the norm consider 2 or 3, and you're having 4 feet from the talker. So the same room with the same acoustic can offer you more PAG value, and you can offer better voice lift system in that kind of scenario. So it's pretty much clear that if you go away from the microphone and if your speaker is coming closer, it can affect the voice lift. So there must be some kind of serious calculation which you need to do. And by the way, this tool is available on our website. Our admin has already shared the link. So if you guys want to look on the tool, how exactly it works, you can just go straight away. You don't need to do the logarithmic calculation, what was shared before. We have simplified this tool for you guys to have the ease of use. Okay, now let's talk about other consideration. What else you need to think about when you implement the voice lift system with microphone and other things. The second thing what you need to consider is equalization. Equalization plays a very important role for the voice lift application. As you know, the voice lift, the biggest challenge for voice lift is to have the feedback in the room because of the speaker and microphone placement and the room acoustic. So with the help of EQ, you can achieve better gain before feedback. How? Let's talk about this. If the room is having ambience issue more on the low end side, you can use high pass filter, cut the low frequencies for some dB, and that can help to give you better response with the same system. EQ also can help you to improve the intelligibility by improving the gain before feedback. And you can also use the notch filtering of the equalization, which will help to cut the specific frequency which is going to affect the voice lift system. For example, if you have a room and you're having a certain frequencies always playing over there because of the HVAC and because of the projector noise and all. So you can find those frequencies and then you can notch it down. So instead of getting picked up by the microphone, those frequency will be notched down. So that can help to not to have the picked up by the microphone, and it gives you more gain before feedback. I'll explain with this slide over here. So this is a slide. This is the snapshot of our Intel MXA 910 ceiling array microphone parametric EQ. So you can see that I have applied 4 EQ setting here. The first one is low cut at 200. As said, most of the feedback, what we see in general in a voice lift scenario, is mostly happening because of the low frequency. And the room is having ambient noise, room is having other kind of noises because of HVAC and all. So those are the low frequencies. So chopping it at 150 or 200 helps because that will not go back to the microphone. Then we have also implemented high cut to cut at 12,000. hertz, that helps to not to be accepted by the microphone for the higher frequency side. And I have given an example of notching down the frequency 1500 at -8 dB. This is just to show you example. Like for example, if you're having a room where the room is having a specific frequency, so what you can do, you can notch down. You first of all, you will find those frequency by boosting certain dB, and then once you find, you notch it down to 3 to 6 dB. That helps to not to be picked up by the microphone, because the pickup for those frequency will reduce to certain dB. So this kind of equalization will help to give you more gain before feedback when you implement the voice lift system. Now, other consideration is the feedback suppression. As mentioned by Anish before, that it becomes quite challenging if your room is having video conferencing application and you apply AEC. So basically, in that kind of scenario, dynamic feedback suppression is not recommended when deploying voice lift in a conference system with AEC. So the idea is to have the separate audio path for voice lift and apply to audio processing accordingly. So you need to have the separate audio path if your room is having voice lift in addition to video conferencing system. Yeah. Having feedback suppression help in suppressing the unwanted instant feedback in the room. As I mentioned before, if room is having unwanted instant feedback, maybe somebody entered into the room, door opened, and somebody was whispering, and those frequency get picked up by the microphone. So at that point, by having the feedback suppression, it helps to find and then immediately notch it down. So you can use feedback suppression to avoid unwanted instant feedback. And when you use the feedback suppression, we recommend to keep couple of bands like 2 or 3 as fixed, which will help in suppressing the constant and always available frequency of the room. And keep couple of bands on dynamic to notch down the instant feedback which can occur by any reason, like doors opening, book drop, and coughing, or crisp packet rustling, etc. I'll explain a little more in detail in my next slide, but you can utilize the feedback suppression this way. Now, to explain where exactly you should not use the feedback suppression, so to explain that, have a look on this slide. This is the audio path for conventional VC room. So over here, and you must be very aware about these kind of audio processing and the audio path, what you use for your conventional AV conferencing system without voice lift. So the microphone comes in over here, it goes to EQ, then echo cancellation, of course, then noise cancellation. Then it goes to auto mixer, where you limit the number of open channels of the microphone, and then you do the processing and you send the audio to the far end. You don't send the microphone signal to the speaker, yeah, because there is no voice lift. It's just the video conference. And the far end audio and program audio from your laptop get mixed up in matrix mixer, then you send it to processing, and then it goes to amplifier and you hear via speaker. So you're just listening the far end and the program audio of your laptop. This is a very straightforward audio path for conventional VC room. Now have a look on this schematic audio path. So over here, the room is definitely having VC call, and you want to have the voice lift. So we don't recommend to have the same audio processing what you do for video conferencing for the voice lift application. What we ask is to split the microphone signal and create a separate path for voice lift application. So this area, what you see here, basically is the standard conventional AV conferencing, video conferencing for the AV conferencing system. And then you take the audio and create a zone, right? So we were talking about mix minus in our previous slide. So over there, and this is the basic concept. Over here, you're routing the audio to the EQ. Then, of course, gated auto mixer. You need gated auto mixer where you can limit the open channels. You don't want to keep unnecessary open channels for the voice lift application, because that can give you kind of instant feedback because you're having many open channels, and that will go to the the speaker will send that signal to the microphone and creates a feedback. So there are two zones here. One is the orange one and second one is the blue. So whatever lobes or the microphones are in zone 2, for example, that will only go zone 1, for example, that will only go to zone 2 speaker. And same, whatever signal and the microphone are for zone 2, that will only go to zone 1 speaker. So you're just segregating in the matrix mixer. You're not going to route the microphone signal in the same zone, because there are two reasons. First, you don't need that because you can directly hear the talker because you're going to be closer to the talker. And secondly, it will help you to give you more gain before feedback if you apply these kind of setup. Now, so this is going to be your basic audio path when you apply voice lift system with VCA application. Now, other consideration what you need to take care is the environmental consideration, size of the room. Remember that large spaces have higher decay times, RT60, reverberation time, RT60 value, and may not be suitable for voice lift, because higher the RT60 value, you are having more possibility of having the speaker output to be heard by microphone, and that can create the loop and you get the feedback. So if needed for the larger spaces, you must need to treat the room. Acoustical treatment is the must for larger size of the room. Secondly is the ambient noise level. So we recommend to have the ambient noise for having the voice lift kind of scenario to somewhere around 35 to 40 dB SPL. So higher the noise level, you require more gain on the speaker side. You need to pump the speaker a little more than what you are supposed to pump at 35 dB SPL of noise level. So when you pump more output on the speaker, the possibility of picking up the output by the microphone becomes higher, and that can lead to the feedback. So try to reduce the ambient noise level. Try to, and it is a challenging thing in a room if the room is having, for example, HVAC is having its own constant ambient noise. So it becomes quite challenging for the old buildings and all. So the solution what we can offer and we can suggest is to have the silencer for the HVAC and all for the old kind of installation. So there are silencer available in the market which can be implemented in the duct of the AC that can reduce the ambient noise, and it can help to give you more gain before feedback. Other thing is interior acoustic, poor result for voice lift. As mentioned, use absorptive material like carpet, acoustic panel, acoustic ceiling tile to improve the acoustic, and which will help you to give you more gain before feedback for the voice lift application. Now, as we are seeing in a couple of months that people are willing to have the social distancing and all, and when somebody is having the microphone on the table, they are hesitant to use it. That's what we are hearing a lot from the market. So people are looking for alternate solution. How exactly we can do we can implement the system without having the microphone on the table. So over here, we start thinking about a microphone which is installed on ceiling. So MXA 910, the one what we have. But the thing is, the question is, can it be done? Can we do the voice lift with MXA ceiling array microphone? The answer is yes. And you can have 7 to 11 dB higher than any conventional microphone like omnidirectional or the cardioid microphone. Performance of 7 to 11 dB higher in typical conference room in comparison of the standard microphone. And why? Let's talk about this. So MXA 910 is having narrow lobes, and lobes are very directional, and because of that, it provides more gain before feedback than any traditional microphone, which is somewhere around 7 to 11 dB. You have there are certain considerations when you want to use ceiling array microphone for the voice lift. It's very simple. It's a simple physics that you are away from the microphone. So the speaker which is close to the microphone can hear, the microphone can hear to the speaker, and it can create the feedback. So you have to have a great care in aiming lobe. So you should not route the audio, or you should not have the speaker near to the microphone. Otherwise, you will get the feedback. Do not aim a lobe into an active zone in which it is routed. So we are talking about mix minus here. We also have a tool which we have designed where you put the value, and that gives a kind of comparison. So the previous one, what you saw, which is available on our website, is going to give you PAG and NAG value, PAG and NAG value. But another tool, what we have developed, is going to give you comparison where you're still doing the PAG NAG calculation, but over here it will give you like what amount of dB you get from ceiling array microphone, what you get with cardioid, and what exactly you can get with omnidirectional microphone. If you guys are working on the voice lift, you want to have the comparison, you can contact us and we can offer you this tool as well. Okay, now let's talk a little bit about lobes. So as you know that our ceiling array microphone offers you three different types of lobe: narrow, medium, and wide. Yeah. So here we are trying to understand why is this microphone different and why do you need to consider more when you do the voice lift with ceiling array microphone. So if you see here, I'm just going to give you a quick overview. If you see the narrow lobe, the area what you see, and here the dotted line and other lines what you see are just sharing the range of frequency, what is getting picked up by the lobe. So 1000 is hertz is dotted line, solid line 2500 hertz, 1500 is like that, and 4000 like that. So if you see the lobe, what you are having with ceiling array microphone are picking up this range for higher frequency like 2500 and 4000. But if you talk about the lower frequency, which is 1000 hertz, the microphone is having the narrow pickup, but it is also going to pick up from other direction because lobes are less directional on low frequencies. When you see this blue area, that is mostly for the higher frequency, which is the human voice and intelligible speech and voice of the person. That is showing over here with the highlighted one. But if the room is having unnecessary ambience, the lobe, which says like it is going to cover in 2 meter, it can also pick at 4 meter for the lower frequencies. Talking about medium lobe is also having a kind of pickup for the lower frequency from the other side. Why? Because the lobes are less directional on lower frequencies. So the higher intelligible frequencies are well picked up by the area what is shown by the lobe, but other frequency can be picked up by outside of the lobe as well. And this is the wider lobe. If you see over here that the wider lobe is more or less like more accurate, and it is showing this almost same kind of pickup for all different frequency range. So if you ask me, I can say that medium and wide are much more natural. Narrow is required if the room is small and you want to pick up the voice for the smaller room and all, then you can consider narrow. For the voice lift, we still recommend to go for the medium lobe by the ceiling array microphone. And this is the example of the cardioid polar pattern, which is wider compared to our any three lobes what you receive from MXA 910. Yeah. So even if the microphone is on ceiling, it is away from the talker, it gives you better pickup for the higher frequencies by any three different types of the lobe. Now, consider, I'm just going to explain a couple of more characteristics of ceiling array microphone. As mentioned before, that lobes are less directional on low frequency. It is 80-degree wide at 500 hertz. So if suppose when we talk about human voice, it is mostly after 1K, right? Where the intelligible frequency of human voice are there. Now, when the microphone is picking up 500, which may be the ambience of the room, so the same lobe, what is at 35, 45, and 55, can become wider for the lower frequency, which is 500. 80 degree for 500 hertz and 120 degree wider at 250 hertz. For your reference, cardioid microphone is having 180 degree wider for 250. 250 hertz of frequency. So it's still the MXC 910 is narrower than the conventional cardioid microphone. Yeah. So as said, lobes are less directional on low frequencies. So have a look. This is the room where we have configured 8 lobe, and these lobes are basically representing the higher frequency, the intelligible frequency of the human voice. But if the room is having ambience, the same lobe becomes wider. You will not see in the GUI. Basically, the same lobe will pick up outside of this area what was showing before, and it will pick up the low frequency from this area, yeah, which we are talking about. HVAC noise and other noise, any kind of ambient noise will be picked up from there. Same applied over here for any other lobe. So the same lobe is picking up more on the low frequency side if the room is not acoustically treated. So if you consider the whole scenario, you're having 8 lobes in a room, it acts like an omnidirectional for the lower frequency, yeah, on the low frequency, which is ambience and all. So same, if you see here, the lobe, which is very intelligible for human voice, and the intelligible frequency is 35, 45, and 55, it becomes 120 degree wider. The same lobe become 120 degree wider for 250 hertz and lower frequencies. And you need to consider that when we talk about cardioid microphone, it's on table. You are closer to the microphone. And now you are talking about keeping the microphone on ceiling. Even if the pickup is narrower than this cardioid microphone, it is on ceiling. And consider 120 degree on ceiling. It is like an omnidirectional microphone. So you have to be very careful what exactly is in surrounding of the microphone. So we don't recommend to have the speakers, ceiling speaker next to the lobes, specifically when you do the voice lift. So you don't need to route the speakers to those lobes. Otherwise, it will go to the feedback. Now, other consideration, what you need to think about is you need to apply the high pass filter, low cut filter, what was said before, and that helps to cut the low frequencies. Now, second consideration is the slope of the filter should be steeper by twice than normal. So 18 to 24 dB versus 6 to 12 dB per octave. Now, what is that? I will explain in my next slide. And note that PEQ filter should be used on output to the louder speaker to reduce room acoustic characteristic. It is always recommended to apply the PEQ at the output side. Now, let's talk about slope of the filter in voice lift. So this is a snapshot of parametric EQ. Here we have one high pass filter and low pass filter. High pass is at 200 hertz and low pass at 12,000 over here. Yeah, there are several filter families. So the one what you see is Linkvis and at 12 dB per octave. Now I'm going to show you the next one. This is the Basel. It's another filter family at 12 dB. You can see the slope is slightly steeper compared to the Linkvis. Why? Because this is a different family, filter family. It is having different way of accepting the voice or the ambience and any kind of sound. Now the third one is Butterworth. Butterworth is even slope is slightly steeper than Basel and Linkvis. And here Butterworth has 12 dB per octave. Now here the one what I was explaining, slope of the filter. So it was at 12 dB, and the next picture is showing 24 dB per octave. So you can see the slope is steeper here compared to the Butterworth at 12 dB per octave. So in a video conferencing and all, we always do 12 dB per octave, which is fine. But when we do the voice lift, our main objective is to avoid unnecessary low frequencies which can create the feedback. So having the steeper slope helps to avoid those. Now, other thing is like if you see here, the slope is steep and still having low frequency after 200 hertz. So you can also add low shelf filter at somewhere around 260, 50 by some dB of gain, minus 9 dB of gain, which will just also help to not to accept unnecessary low frequencies. Yeah, so that helps to avoid the low frequency. And here I'm showing the slopes, what you can have with different filter family. And these are the notch filter. As I said, if the room is having a specific frequency, we always recommend to notch it down, which helps to not to have the feedback by the system. So this is a complete scenario, what you need to look on when you use the DSP to have the better gain before feedback. Now, next is the room type and environment. Over here, voice lift in a smaller room is not possible with ceiling array microphone. The distance from the talker to the listener, the nearest listener in the voice lift scenario, where exactly you need to have the voice lift, is 25 feet. If somebody is sitting in the middle of this table, the guy who is going to sit here will easily hear to the talker because he is just close to the talker. But the voice lift is going to be mandatory if the distance from the talker to the listener is far, or minimum is recommended for 25 feet. As said, higher ambient noise level negatively impact the success of voice lift systems. So the room has to have the acoustical treatment, low noise level in the room. Now, talking about the loudspeaker zone, you have to have the zoning to do the mix minus, which was explained before. So consider you're having zone 1 and zone 2. Now, when you do the mix minus, suppose you have a microphone at one side, which will only pick and steer, the lobe will be steered to one direction, which will pick up the talker from zone 1, and that will be projected to the speaker, which is in zone 1 over here for this listener. And you can see the distance is somewhere around 25 feet. Same applied for other party as well. So the microphone which will be implemented for the talker in this direction on left hand side, the audio from there will come from this side only. So you're not going to route the audio to this one because it will immediately get the feedback, right? So the overall, the complete scenario is going to be the microphone from one end will listen to the talker, you will hear the audio at other end, and the microphone which is picking up to this guy will be heard by this speaker on that side. Okay, so when you're having two zone, you need to consider that way. Now, other thing what you need to consider is how exactly you're going to do the matrixing. So over here, I have given a scenario in this slide. There is mic 1, zone 1, and mic 2, zone 2. And you're having 6 speakers in the room, right? And to give you a more precise answer, the distance from the microphone to this speaker is somewhere around 18 to 20 feet. And the farthest speaker is somewhere around more than 25 feet. And same applied on other side as well, 18 to 20 feet and more than 25 feet. So when you use the matrix mixer and do the mix minus, you need to do this. So as I said, if the microphone is here and the talker is sitting near to this speaker, you don't need any kind of voice lift because the listener over here can easily hear to the talker without having any kind of technology required. So you are not going to route any audio from this microphone to the nearest speaker. When you reach somewhere around 18 to 20 feet, and for example, you give 0 dB to this speaker, yes, fine. So it will give some kind of voice lift. And when you go away more than 25 feet, you give 5 dB or 6 dB or maybe 7 dB or maybe 3 dB, depends. You need to hear before implementing, and basically when you implement, you need to hear and observe what's happening. So what I'm trying to explain here, there is no audio to the nearest speaker. You give few dB to the second one, which is going to be zone 2, and more dB on the farthest speaker. And same applied on other side as well. So no routing to this speaker, 0 dB or few dB on the next one, which is far, which is away from the microphone, and more dB on the farthest speaker. So this is how you do the voice lift, and it can easily be done via matrix mixer. Okay. Now, so let's review the key concepts. What you need to consider when you do the voice lift? Determine suitability of the room for voice lift, size important, acoustical condition important, and client expectation. it is very important to set the expectation of the client. Some client can say like, okay, I want to have the voice lift with the system. I want to have the reinforcement, but reinforcement is completely different than the voice lift. Reinforcement is like you having a microphone closer to you, and then you pump the speaker with maximum dB and it will not go for the feedback because you are closer to the microphone, the speaker is away from the microphone. But when we do the voice lift, it is a minimal amount of gain which is required to compensate the natural loss of the human voice over the distance. So you need to explain and set the expectation. Client should not expect that it is going to act like a PA system. Yeah, as mentioned by Anish before, you have to explain what exactly you get with the voice lift. Second is calculate peg neck, employ loudspeaker zones with DSP, right? And speaker with narrow dispersion angle is recommended. What happens? Like if the dispersion angle is wider, there is a possibility to get more pickup by the microphone lobes to the output. If the dispersion angle is narrow, then the lobe is going to have less possibility to pick up those because the throw from the speaker is going to be narrow. Yeah, so you can look on the speakers which are having narrow dispersion angle. Standard speakers are going to give you a dispersion angle of somewhere around 120 degree to 130. If you get the speaker which is having less than 100 degree of dispersion angle, it sounds great for voice lift. Yeah, but of course, when you do the calculation, and even if you're having 120 and 130 degree of dispersion angle with the speaker, still you can achieve the voice lift. Yeah, but better performance can also be achieved by having the narrow dispersion angle. Select the right microphone type and apply the equalization. Now, I'm going to show you a couple of use cases where we have done the voice lift. So that can at least give you an idea of what exactly we can do with ceiling array microphone, which was implemented and running successfully. So this is a layout of 100-seat multipurpose divisible room. The size of the room was 60 feet by 30 feet and ceiling height is 9 feet. And we have implemented the voice lift like this. The 2 microphone, speaker zoning, lobes like that, and the voice lift was possible. Again, it's the divisible room and multi-purpose. So there are different seating arrangements. So the same microphone can offer the different pickup by changing the seating arrangement. You can apply the presets in microphone and the lobe will readjust itself for different pickup. And it was done for 100-seater room, which worked pretty well for the voice lift. Now, the second example what I could show, which is done already, 100-seater auditorium. The length and width was 40 by 40 feet and ceiling height somewhere around 10 feet. And we implemented the voice lift system with 6 ceiling array microphone. You see, we are not using unnecessary lobes. The microphone can offer up to 8 lobes, but we are covering the whole area with 3 lobes only. It is always recommended to use the amount of lobe what is required for the voice lift, not use unnecessary lobe which can add more pickup. So be a little bit calculative when you do the voice lift. So lobes were configured like this. Now the third example use case is what I can show you is the 230-seat auditorium. And you can see the ceiling is having angles. It's on slope. And we installed ceiling array microphone. Ceiling height was 11 to 15 feet of range. And we did the speaker zoning here. So you see there's 3 speakers are in one zone, here 3 speakers in another zone, and the whole area is one zone. So what we did, we used 4 ceiling array microphone, yeah, and configured the lobe this way, yeah, and the audio what was picked up by this microphone was getting heard by these speakers on other side, yeah. Same way, whatever was getting picked up from this side was getting played on other side. So mix minus. The reason why we were able to do this 230-seat of auditorium because the auditorium was acoustically treated. As I said, when you're having a large space, you have more RT60 value. We recommend to treat the room if you want to have the voice lift in such kind of larger spaces. And we have done this. So we are pretty much confident if you are having certain project and you want to discuss, we can discuss and somehow do the calculation to help you to design the voice lift. considering all the factors what we discussed. Yeah, that has to be considered. Yeah. Now, talking about all these what we discussed here, we are going to give you these link. You can take a screenshot or maybe you can take a picture. So these all are the technical training available on our website where you can learn more about VoiceLift. It's more or less what we discussed, but you're going to have the tool in front of you if you are working on any project and all. So PagNet calculator with this link, webinar, for maximizing gain before feedback, you can use this, and how to use MXA910 ceiling array microphone for VoiceLift. So you can use these documents and the link to learn more about the VoiceLift with our system, what we can offer. So that's all from my side. Let me summarize the course summary. By now, you should be able to determine if your facility is reasonable candidate for the VoiceLift system or no. Select a microphone system that will allow you to obtain your desired result. Calculate the amount of gain if you can expect to achieve as part of your system design, and determine if the performance benefit justifies the cost of implementation. Yeah, that's important. When you set the expectation, you also need to explain the cost, what is going to be there with their expectation. If that's matching, then only you can go ahead by implementing the system. Yeah, we would request you guys to register yourself for our online training portal. This is our Talent LMS Shure MEA page, where you can learn, where you can go and learn a lot of training. You can learn a lot about our products on this. So register yourself. You will get a lot of knowledge from there. So this SAI page, Shure Audio Institute page, is having almost all the webinars and all what we have done over here, and you can learn a lot from here. So feel free to register. It's free, and a couple of trainings over here also gives you a CTS RU point, which can help you to renew your CTS license, CTS certification. If you guys are having any questions, any doubt, you want to discuss something with us, this is our email address, support_miyasa@shure.com. You guys can contact us on this email. We are the one who receive those emails, so we can respond you back from here. Thank you, guys.